So if somebody asks you to define capacitance straightforward, then it is electric charge divided by electric potential. But if the question is to define a capacitance of a parallel plate capacitor, then you have to define which charge on each plate, and which potential difference between the plates. Statements become bigger, but it is still the same thing. But it will get you 2 marks over there. Three capacitors of capacitance C1, C2, and C3 are initially uncharged. They are then connected in series to a battery, as shown in the diagram. The battery applies a potential difference V across the three capacitors, show that the combined capacitance is this. It is a 2 mark question, and if you go back to notes, you can see the detailed way of doing this. But if it comes in exam, you should know that uh, because these three capacitors are connected in series, they will be sharing the potential difference across them. So C1 has V1, C2 has V2, C3 has V3. One thing that you can say for sure is V equals to V1 plus V2 plus V3. But we know V equals to total charge divided by total capacitance. V1 equals to the same charge divided by capacitance of 1. V2 will be same charge divided by capacitance of 2. V3 is same charge divided by capacitance of 3. So if I put all these values into this expression, I will get Q over C equals to Q over C1 plus Q over C2 plus Q over C3. So if I take 2 common from the right hand side, I will left with 1 over C1 plus 1 over C2 plus 1 over C3 equals to Q over C. I hope you can see that if I shift Q from either side to the other side, it will be in the denominator and it will get cancelled. So Q and Q get cancelled, and I will left with 1 over C equals to 1 over C1 plus 1 over C2 plus 1 over C3. And that's it. And shown. Okay. So this is how you're supposed to do this in exam. Straightforward. Now, a battery of EMF 12 volt and negligible internal resistance is connected to the network of two capacitors and a resistor as shown. The capacitors have capacitances 200 microfarad and 600 microfarad. The switch has two positions. So this switch can either be at A like this. That is how this should be connected if you want to charge the capacitors. And it can also be like this. When the 600 microfarad capacitor will be connected in series with the resistor. Like in that case, there will be a short circuit over there. Not short circuit in terms of a short circuit. It means a smaller circuit. Okay, that will be delivering its own current to the resistor, and this current will be coming from the energy stored in the capacitor. So this switch can either be on B, and in that time the capacitor will be discharging, and it can be at A. At that time, the capacitor will be getting charged. Now, the capacitor is so and so and so. The switch is moved to position A. Calculate the combined capacitance of the two capacitors. Now, there are two capacitors which are connected in series. So, method one is 1 over C equals to 1 over 200 plus 1 over 600. So 600, 300 plus 1. Not 300, it is 3. 3 plus 1 equals to 1 over C. So C equals to 600 divided by 4, which is 150 microfarad. Okay, if you are like me and you don't like fraction, I don't like fractions. I hate fractions because look, I was about to make a mistake over there. So sometimes, sometimes I avoid these LCMs and reciprocal thing. What I do is, if there are only two capacitors, the total capacitance equals to product over sum. So in that case, I do not have to reverse the final answer, but it can only work for two capacitors that are connected in series. Product over sum means 600 multiplied by 200 divided by 600 plus 200. So it will be 12 with four zeros divided by 800. So cancelled, 8 ones the 8, 8 ones the 8, 4 gets carried, 5 and 0. So you get 150 microfarad. Or you can simply use the calculator. 600 multiplied by 200 over 600 plus 200. You get on. The charge on the plate on the 600 microfarad capacitor. What is the charge stored? Now, it is it is a trick question. You know why? Because when the capacitors are in series like this, when capacitors are in series, the charge stored on this one and charge stored on this one has to be same, and that has to be same charge that comes out of the battery. So if the total capacitance is 150 microfarad and potential difference, the battery is 12 volt. So what will be the charge? I hope you remember that the charge equals to CV. So it will be 12 multiplied by 150 into 10 to the power minus 6. 0, 0, 6, 8. So it will be 1.8 into 10 to the power minus 3 coulomb. So that will be the charge that is coming from the battery. That will be the charge on 200 microfarad capacitor, and that will be the charge on 600 microfarad capacitor as well. Because in series, all of the capacitors get same potential difference. Sorry, same electric charge. Now, the potential difference across this one. So if you know capacitance is 600 microfarad, or I should say into 10 to the power minus 6 farad, and charge is 1.8 into 10 to the power minus 3 coulomb, and we need potential difference. I hope you know potential difference equals to charge divided by capacitance. So 1.8 into 10 to the power minus 3 divided by 600 into 10 to the power minus 6. So it is 0.3 into 10 to the power 1. I'm getting 3.0 volt. Can somebody confirm with a calculator? I do not have one right now.
Yes, sir. It's 3.0.
So that means that this capacitor will get 3 volt and this capacitor will get 9 volt. Now, the switch is now move from position A to B, calculate the potential difference across the capacitor, across a 600 microfarad capacitor when it has discharged 50% of its energy. Now, what is the formula for energy? Energy equals to 1 over 2 CV square. Initial energy, there is one mathematical way of doing this, and there is one physics way of doing this. So here we go. E equals to 1 over 2 CV square. So when full, it will be 1 over 2 into C is 600 into 10 to the power minus 6 multiplied by V is 3 into 3, 9. So 300, 3 into 3, 9, 2700 into 10 to the power minus 6, which is 2.7 into 10 to the power minus 3 joule. So 2.7 millijoule. When half, now energy is half. Half energy will be 1.35 into 10 to the power minus 3 joule. Capacitance will still be 600 microfarad. And we need to find out potential difference. So we will again use the same formula and put these new values in and find out the new potential difference. Okay. Now, 1.35 into 10 to the power minus 3 equals to 1 over 2 into C is 600 into 10 to the power minus 6 V square. So V square equals to 2.7 into 10 to the power minus 3 divided by 6.0 into 10 to the power minus 4. And if we are finding V, so there will be a square root like this. So it is 10, 0.45, 4.5 square root. So what will be the square root of 4.5? So it will be 2.12 volts. Okay. Side by side, you should all be holding a calculator and check the calculation.
Yes, sir. The same.
Hmm? Now, this is one way of doing it. Now, if this is a mathematical way of doing this. If you don't want to do it with mathematical way, the alternate method is E is directly proportional to V square. So if this is 1, this is 3 square. If this is 0.5, this is x square. Okay. So x square equals to 0.5 into 9. X equals to 0.5 into 9 square root. And you will get 2.12 volts. Okay. Because if you know the relationship and energy equals to 1 over 2 CV, 1 over 2 is a constant, C is a constant, capacitance of the capacitor does not change. Whether capacitor is full or half, it has the same capacity. Okay, it is like a 1 liter box, 1 liter box. If it has a liter of milk inside, it has a capacity of 1 liter. And if it is even empty, its capacity is 1 liter. So capacitance does not change. So capacitance is constant, half is a constant, so it means energy and potential difference square are directly proportional. So this would be an easier way, but this can only be done if you have a crystal clear concept and crystal clear understanding what examiner is actually asking for. So if energy is one, well, the voltage is three. If energy becomes 0.5, voltage becomes X. Because there are square on V, so we will put squares on every V that we are considering, and then we can find out. So this is an easier way of doing all this. But some people are more comfortable with the formula. So it is totally your choice. Okay, hope you understand. Now, let's do another capacitance question. Here we go. Here is a question. A student sets up the circuit shown in figure 7.1, measures the charge on the capacitor C for different values of potential difference across the capacitor. Now, potential difference and charge is measured. The potential difference charge capacitor is shown. State and explain. Figure 7.2 indicates that there is a systematic error in the reading of one of the meters. Uh, on the diagram, what you could do is you could make a best fit diagram. Okay. So this is a best fit diagram. Why it is best fit diagram? Because two of the points are on the line, two of the points are above line, and two of the points are below line. So this is a perfect best fit line. Now,
Sir, could you repeat this part?
listen, the examiner has given you a question in which he has given you dots that he measured potential difference and charge stored on each plate. Then he put the, the points on the grid. One of the point is here and one of the point is here. What is the way of making a best fit line? When you draw a line, you have to be very careful that you miss some of the point above line and some of the points should be missed below line. So if you have equal points above and below line, that is the best fit line. Now, this is where the line intersects the x-axis. So it is 0.60 volt. Actually, when there is no charge, potential difference should be zero, but it is not. When there is no charge, reading on voltmeter should be zero, but it is instead 0.60 volt. This is a zero error, which is a Systematic error. So he asked for that explain why there is a systematic error. And I told him that because when I drew the best fit line, it was intersecting x-axis at 0.6 volt. It was showing that when there is no charge, still there is a potential difference of 0.6 volt, and this can only be if the voltmeter is faulty. The voltmeter shows 0.6 when actual reading is 0. Such a problem on any device that does not show 0 when reading is 0, it is called a zero error. So this voltmeter that has been used for this experiment had a 0 error. Now, the capacitance in microfarad for capacitor C. If you have a graph of charge and voltage, what feature of this graph actually gives you capacitance? Is it the gradient or the area?
The gradient.
The gradient. So to find gradient, we have to select 2 points on the line. So what we do is, for the easement, we take a vertical line here. As big as possible is the best. So this value is 5.9. This is 0.6. So the run will be 5.3 and rise will be, oh, watch this one. Keep your eyes open. Okay. So there is a milli over there. It means any value that you take from the y-axis has to come with a built-in milli over there. So if you think it is 15, no, it is 15 millicoulomb. So the height will be 15 millicoulomb. The gradient will be capacitance equals to 15 into 10 to the power minus 3 divided by 5.3. Actually, it is 5.9 minus 0.6. So what will be the value? 0.015 divided by 5.3. So it will be 0.0028. 0.0028. So it will be 2.8 into 10 to the power minus 3 farad. Oh, he is asking it to be in microfarad. That will be 2800 into 10 to the power minus 6 farad. Okay. Every millifarad has 1000 microfarad. So when you're converting 2.8 millifarad to microfarad, you come to 2800 microfarad, excuse me. Now, use the answer to determine the additional energy stored in the capacitor C when the potential difference across it increased from 6 volt to 9 volt. Okay, we cannot do it from here because the graph is not. So energy formula is 1 over 2 CV square. But change of energy formula is 1 over 2 C V2 square minus V1 square. 1 over 2 and capacitance is 2.8 into 10 to the power minus 3 into 9 square minus 6 square. 81 minus 36. 45. 5 into 2, it will be 6.3 into 10 to the power minus 2. Can anybody confirm with a calculator?
Yes, sir.
Yes,
It's
sir.
So this is how you're supposed to solve these kind of questions. Okay,
So what if we just write in point like 0.063?
that is perfectly fine.
Okay, so
It should have two significant figures, 6 and 3, no matter how many decimals or zeros are over there, but two non-zero numbers should be there. Okay, rest of the questions are yours. You can practice them by yourself. I'm sharing the PDF of this thing with you, so you can see the old notes. See you people tomorrow. Okay.
Okay, so Assalamu alaikum.
Walaikum assalam.
okay, sir. Good night, sir.
Thank you.
So if it get completes, then kindly share it by tomorrow or day after tomorrow.
Okay, I will. I will.
Okay, sir.
Hello, Hassan. I'm fine, thank you. Okay, I will. I will. Uh, I can see that. I can see that. So, uh, I actually another student was asking for the same thing. I'm working on my drive. Something went wrong, and I'm still trying to get to my drive again. I think it will be sorted by tomorrow or day after tomorrow. So then I'll be able to send you the previous recordings. But by the day and today, I will be sending you the recording of today's lesson. Yes, you're welcome.